Hi, everybody. We are learning about the Pythagorean Theorem today. This is one of my very favorite lessons to do. This is an 8th grade standard, so I use this with my advanced 7th grade class. So, the Pythagorean Theorem. It's named after the Greek mathematician Pythagoras, and it's used to find the missing side of a right triangle. It has to have a right angle. If it's not a right triangle, this thing doesn't work at all. So, let's talk about right triangles for a minute. Your right triangle, you have to have your 90-degree angle, right? Okay. The two sides of your triangle that make up that right angle, in other words, you've got this little square box symbol that means right angle. The sides that make up the rest of that box, those are your legs. You're going to call one of them A and the other one B. It doesn't matter which one's which, but the two legs, the two sides that make up the right triangle, one of them has to be A, the other one has to be B. The third side is the longest side. It's across from the right angle. That one's called your hypotenuse, and that one has to be C. So where the legs, you can pick what's A and B. The hypotenuse, you have no choice. You have to make it C. The Pythagorean theorem says A squared plus B squared equals C squared. So we're going to take a leg times itself, the other leg times itself. We're going to add those together. That gives me the hypotenuse squared. So once we get that answer, we'll want to take the square root to figure out what the length of the hypotenuse really is. Let me show you. Let me switch back to a pen here. Okay. So the first thing I want you to always do is figure out which side is going to be your C. So I'm going to draw an arrow through my right angle symbol, and that arrow will always point to your hypotenuse. So in this one, the side that I'm missing is the C. So I'm going to write down A squared plus B squared equals C squared. And then I'm going to plug in my information. Pick one of the legs to be pick one of the legs to be A and pick the other one to be B. The only one that really, really matters is where your C is. So I'm going to do 8 squared plus 6 squared equals C squared. Order of operations, I can't add anything until I multiply those, till I do my exponents, right? So 8 squared is 64 plus 6 squared is 36, and that equals C squared. 64 and 36 is 100, but that's C squared, and we want to know what C is. So the opposite of squaring something is taking the square root. The square root of 100 is 10. So my missing side length is a 10. Let's do another one. On the second problem here, you need to figure out, you know what I did? Oh my goodness. So when I wrote this problem, I was using what's called a Pythagorean triple. There's some combinations of 3 side lengths that are whole numbers that will always work in your Pythagorean theorem. And one of them is 3, 4, 5. So when I set up my 3 and my 4, I already knew I was planning on it being 5. So I definitely wrote the 5 instead of the C. That would be my bad. But hey, you know what? I didn't necessarily plan on talking about Pythagorean triples. And there you go. I just explained. The one we just did actually with the 6, 8, 10. That's another Pythagorean triple. Anytime when you have whole numbers like that work in A squared plus B squared equals C squared, then it's called a Pythagorean triple. So anyway, we are going to try this one again. You're going to pretend like you never saw that 5, and we are going to figure out what that mystery side is, right? Okay, so I'm going to draw my arrow through my right angle symbol, and that's going to point to the hypotenuse. So even if I had this labeled as X, like the problem we did before, I still know I'm going to use that one as C because it's the hypotenuse. Pick one of the legs to be A, the other one to be B. Doesn't matter. I'm plugging this into A squared plus B squared equals C squared. I'm going to do 3 squared plus 4 squared equals C squared. And the reason why the A and the B are interchangeable, addition's commutative, right? So after I do my exponents, that's going to be a 9 and a 16. 9 plus 16 is the same as 16 plus 9. That's why it doesn't matter which one's which. So this says 9 plus 16 equals C squared. Add those together, you get 25 equals c squared. But we don't want c squared, we want c. So the opposite of squaring something is taking square root. And I know, big shock, you had no idea on this one, right? You hadn't seen it before or anything. Your missing side length is a 5. Let's do another one. So on the third one here, I'm going to draw an arrow through the right angle symbol. It's going to point to the hypotenuse. So again, I'm finding c. A squared plus b squared equals c squared. I'm going to do 10 squared plus 12 squared equals c squared. And then order of operations, exponents happens next. That's 100 plus 144 equals c squared. Add those together, that's 244 equals c squared. 244 is not a perfect square. So in my calculator, I know that the square root of 256 would be 16. So this is going to be a little bit less than 16. But I'm going to use a calculator to see exactly what it is. So 244 square root, I get about 15.6. So there's 3 examples where you're missing your hypotenuse, but you're not always missing the hypotenuse. Sometimes you're missing one of the legs. So on this one, identify which one is C. On this first one here, your C would be the 13 because it's across from the right angle. Pick one of them to be A, one to be B, it doesn't matter. I'm going to do x squared plus 5 squared equals 13 squared. So that's x squared plus 25 equals 169. Now, it's basically like a 2-step equation. We've got to solve it for x. So I want to get rid of that 25. I'm going to subtract 25 from both sides. And that leaves me with x squared equals 144. But I don't want x squared, I want x. So I'm going to take the square root. And I find out that your missing side has to be 12. That's another one of those Pythagorean triples. So when I set up this example, I knew if I used 5, 12, 13, then it would work because I had to memorize those way back in the day. So Pythagorean triple when they're all whole numbers. Let's try another one. I'm going to identify the hypotenuse. So C goes here. And then I never actually labeled this one. You can put an X, you can put an A, you can put a B, whatever. So I'm going to do 2 squared plus my mystery side squared equals 3 squared. So that's 4 plus x squared equals 9. To get x squared by itself, I need to subtract the 4. So then I'm left with x squared equals 5. To solve for x, the opposite of squaring is taking the square root. The square root of 5, that's a little bit bigger than the square root of 4, which would be 2. So this is going to be a little bit bigger than 2. 5 square root, it's about 2.2. Just try one more like that. Identify which one is your hypotenuse. So this is the C here. I'm going to do x squared plus 15 squared equals 20 squared. So then I do my exponents. X squared plus 225 equals 400. To get x squared by itself, I need to subtract the 225. That gives me x squared equals, why won't it write? There it goes, sorry, 175. Opposite of squaring is taking the square root. So let's see, the square root of 175 is about 13.2. Okay, so they all work the same. A squared plus b squared equals c squared. You just have to remember that c has to be the hypotenuse. Let's do a couple word problems. Pythagorean theorem, this is one of those things that you can absolutely use in the real world for situations like this. I mean, no, you may not be necessarily needing to figure this out exactly. You may just by trial and error lean up a ladder and see what works. But sometimes you do need to plan ahead. If you are building a deck, for instance, I had a friend not long ago who was building a deck, and he said, oh my gosh, all those times we learned about the Pythagorean theorem, I actually used it. If you want to measure things and make them work properly, make them stand up straight, make everything sturdy, sometimes you actually need to use this thing. So this says a ladder is leaning against a house. Let's get a picture. This vertical line is going to represent my house because hopefully it is standing vertically and it's not leaning, right? I've got a ladder that's leaning up against it. Oh, if it'll write. It hasn't been doing too bad, and now my stylus is starting to poop out on me again. Maybe it's the Jamboard program. Who knows? Anyway, so there's my ladder leaning up against it. And like we said, we hope that our house is standing straight. So this makes a right triangle. Okay, the top of the ladder reaches a window 15 feet above the ground. So the window's up here, and it's 15 feet above the ground. If the bottom of the ladder is 8 feet from the house, so this is 8 feet, I want to know how tall is the ladder. I know that ladder is the hypotenuse. That's my C. So one of these is A, one of them is B. It doesn't really matter. Just pick. I'm going to do 8 squared plus 15 squared equals C squared. So that's 64 plus 225 equals C squared. Add those together, you get 289. But you don't want C squared, you want C. So we're going to take the square root, and the square root of 289 is 17. That ladder is 17 feet tall. Let's look at one more. Computer screens, TV screens, when you're hearing that measurement of how big it is, what they're actually giving you is the length of its diagonal. So there's this computer screen, and it's advertised or listed as being a 19-inch computer screen. So here's my screen. What they're saying is this diagonal is 19. It says the height of the screen is 10 inches. I want to know how long is the screen. Well, I'm assuming it's a rectangle, right? So this could be a right angle. So across from my right angle, that 19 was my hypotenuse. So I need to know something squared plus 10 squared equals 19 squared. So then I'm going to do my exponents. A squared plus 100 equals, I think that's 361, right? Let's double check. I always second guess myself when I'm making the videos, afraid that I'm going to make some really stupid mistake. Yeah, 361. To get a squared by itself, I want to subtract 100. So that gives me a squared equals 261. That's not a perfect square. So when I do the square root of 261, I get about 16.2 inches. Okay. Last little thing that goes along with this. I mentioned at the very beginning that the Pythagorean theorem only works for right triangles. So if the numbers work in the Pythagorean theorem, that means it had to be a right triangle. If the Pythagorean theorem doesn't work, then there's no way it could be a right triangle. The longest side will always be C because the hypotenuse is always the biggest side. It's across from the biggest angle, the 90-degree angle, so it has to be the biggest side. I'm going to call this A, I'm going to call this B, I'm going to call this C. So I'm going to see if 1.2 squared plus 1.6 squared really does equal 2.0 squared. 1.2 times itself is 1.44 plus 1.6 times itself is 2.56. 2.0 times itself is 4. If you add those together, it works. So because that works, yes, it was a right triangle. On this one, the biggest side is C. So one of the others is A and the other one's B. It doesn't matter. I'm going to say 10 squared plus 14 squared. I want to know if that really does equal 18 squared. So 10 squared is 100 plus 196 equals 324. If you add that together, it says 296 equals 324. That's not true. So because that doesn't work, there's no way that those three side lengths made a right triangle. And that is the Pythagorean theorem. So thanks for hanging with me until the end of the video. Hopefully it helped you some. If you need to get to 7th and 8th grade math videos quickly, go ahead and subscribe. My channel's Math with Luger. And if you ever need to get a hold of me, there's my school email. So thank you so much. And until next time, bye.